Hello, this is Dr. Hanaa Assil, and this is Unit 5 of June 2024 in the Pearson Edexcel International A-Level. We're going to look at the questions and discuss the answers. So the first question in this paper was, what color is vanadium 3 in aqueous solution? Remember, you are required to know colors of several of the transition metals in different oxidation states. So vanadium, for example, you should know vanadium 2 plus is, or plus 2 is purple. Vanadium in the plus 3 oxidation state is green. Vanadium in the plus 4 is blue, and in the plus 5 it is yellow. So we're being asked what is the color in plus 3, that is. An oxide of vanadium is the catalyst in one step of the contact process for manufacture of sulfuric acid. Which reaction involves the vanadium oxide catalyst, and how does the oxidation number of vanadium change during the process? Okay, so we are talking about manufacture of sulfuric acid. This involves burning of sulfur in air to form sulfur dioxide, and then the sulfur dioxide is changed into sulfur trioxide using the V2O5 catalyst. So actually our reaction that we're talking about is SO2 going to SO3. Now, how does the catalyst work? You should know that the V2O5 reacts with the SO2 to form V2O4, and then the V2O4 reacts with the oxygen to regenerate the catalyst. Now, what oxidation numbers are being formed? In V2O5, vanadium is plus 5. In V2O4, it becomes plus 4, and then it is regenerated in the plus 5. So this is our answer. An equation for the reaction of FeSO4 with KMnO4 is shown, which shows the changes in oxidation states for iron and manganese. You should know how to calculate oxidation states. So if we look at this equation, what is happening to the iron? FeSO4, the SO4 alone is a minus 2, so the Fe is plus 2. While in Fe2SO4 bracket 3, the SO4, each of them is a minus 2, so that's minus 6. I have 2 iron, then each of them is plus 3. The KMnO4 is changing from, the manganese in KMnO4 is a plus 7. You should know how to get that. Each oxygen is minus 2. 2 times 4 is minus 8. Potassium is in group 1, so that's plus 1. So the manganese has to be plus 7 to have an overall 0. MnSO4, if you look at the SO4 as an entity, it's minus 2. Then the manganese is plus 2. So these are the oxidation states. A 25 centimeter cubed sample of FeSO4 dissolved in acid required 22.50 centimeter cubed of 0.1 mole per decimeter cubed KMnO4 for complete reaction. What is the concentration of FeSO4? You should be able to do these calculations. There are always several questions on calculations. So what do we have here? We have FeSO4 in that equation, and he's saying I have 25 centimeter cubed of that. I'm titrating it with potassium permanganate, volume and concentration, so I can get the number of moles of potassium permanganate, concentration times volume. Again, do not forget to divide the volume by 1,000 to change it to decimeter cubed. So this is the number of moles of KMnO4. And then I go to the equation and I relate it with the FeSO4. You can see from the equation that 2 moles of KMnO4 require 10 moles of FeSO4, and that means that the number of moles of SO4 is about 5 times the number of moles of the potassium permanganate, so that's it. And then we're asked for what? Concentration. Concentration is number of moles over the volume. Divide that number of moles by the volume in decimeter cubed, and this gives you the concentration. The EMF of the cell, made up of copper and magnesium half cells, is measured under standard conditions. The voltmeter used has an uncertainty of 0.5%. What is the highest EMF that could be measured in this experiment? Okay, we need to find out first this setup of copper half cells with magnesium half cells. You should realize that the magnesium, what is happening here is the magnesium is changing to Mg2+. If I look at the data booklet, I have an equation for the reduction of 2+, but here I have oxidation, so I'm going to invert that first equation. And remember, when we invert the equation, we invert the sign. The copper 2+ is reduced to copper, and that means the overall E cell is the addition of these two, and that is plus 2.71. Now he's saying that there is a measurement uncertainty of 0.5%. That means the actual correct answer could either be 0.5% above this or 0.5% below this. He wants the highest, so the highest would be 0.5% of the 2.71, and you're going to add that to the 2.71, so the highest value, due to the uncertainty, the highest value could be 2.72 volts. Which is the diagram for the cell made up of nickel and zinc half cells that gives a positive value for the E cell? So if I'm talking about zinc and nickel, zinc is the one that will be oxidized, nickel 2+ will be reduced to nickel. So these are the two half equations that I need. Remember that anything at the top of the reduction potentials, anything with a negative reduction potential is a more reactive metal, and that means that is the one that is going to be oxidized. So in our data booklet, you will have the value zinc 2+ at the top of the data booklet. So that is the one where you will have oxidation, and the nickel is somewhere below, so that is or a more positive reduction potential, so that would be the one that is reduced. So how do we write the diagram for this cell? We start with the oxidation part on the left. So what we have is oxidation of zinc to zinc 2+. And then we have a salt bridge, which is indicated by the double line. And then in the other half cell, what we have is the nickel 2+ being reduced to form nickel. So this is the cell diagram. Which graph shows the relationship between E cell plotted on the x-axis and delta S total on the y-axis? Remember that the more positive the delta S total, the more positive is the E cell, so it's actually a direct proportionality. So this would be the graph between the E cell and the delta S total. Which type of data is not used as evidence for the structure or stability of the benzene ring? Remember the benzene ring? First, there was the suggestion of the Kekulé structures in which we have alternating single and double bonds. But then, if we have alternating single and double bonds, then they should be of different lengths, because a double bond is shorter than a single bond, but then X-ray diffraction, for example, shows that all the bonds in the benzene are the same length, and therefore there is a delocalized electrons of the p orbitals of all the carbon atoms are said to be delocalized over the benzene ring, so that all the bonds are of the same length. Also, the evidence that if we have alternating single and double bonds, then we should have two types of 1,2-dichlorobenzene, in which the two chlorines have a single bond between them, or the two chlorines have a double bond between them, and this two structures have never been found, or they've never been proved to be found. So that means that we can use infrared spectroscopy to determine the structure. We use thermochemical information, we use X-ray diffraction, but the one that we do not use is the mass spectrometry. The formation of nitrobenzene requires benzene and concentrated nitric acid and sulfuric acid, which is an equation for the reaction to form the electrophile. Remember that in order to put a nitro group on the benzene ring, we need to react it with concentrated nitric in presence of concentrated sulfuric. And this is because this kind of reaction between the nitric acid and the sulfuric acid happens in order to form the electrophile, which is the nitronium ion or the NO2 plus. So this is actually the equation to form the nitronium ion, and that is this one. Now we know that what happens is the benzene ring attacks the nitronium ion in an electrophilic substitution reaction in order to put the NO2 on the benzene ring. Please learn this mechanism. Then question 9 says phenol reacts with bromine to form 2,4,6-tribromophenol, and the question is, what is the percentage atom economy for formation of 2,4,6-tribromophenol? Remember, percent atom economy, how do we calculate that? It is the molar mass, or the MR, of the desired product that we're looking at, which is here 2,4,6-tribromophenol, over the sum of the molar masses of all the products times 100. So that means the atom economy is the MR of the tribromophenol over the MR of the tribromophenol plus, remember, we have 3 HBRs. Please take into consideration the coefficients in this calculation. So we have 3 HBRs, then the atom economy for the production of this compound is 57.7%. When 5 grams of phenol was reacted and purified, the percent yield was 76.8%. What mass of purified tribromophenol was formed? Now, we have 5 grams of phenol, so I can calculate how much product I should get. So if we have the 5 grams of phenol, number of moles of phenol is mass over molecular mass of phenol, and that is the number of moles. Now looking at the equation, the number of moles of the phenol is the same as number of moles of the product. So number of moles of the product that we should get is this, and that means the mass that I should get, the theoretical mass, is number of moles times MR of the product. So we were supposed to get 17.6 grams, but that is if it is 100% yield. This is the maximum amount of yield that I could get. Now, if the yield is 76.8%, actually I got only 76.8% of that, and that means the product was 13.5 grams. Aspartic acid is a naturally occurring amino acid. Which form of aspartic acid is formed at pH 12? Now remember, this is an amino acid. Amino acids in neutral pH, they occur in the form of a Zwitter ion, in which the amine part is NH3 plus and the acid part is COO minus. So that is at neutral pH. Now, if we put it in an acidic pH, which is a low pH, then the amine part is NH3 plus and the acid is a COOH. Here we're putting it at pH 12. pH 12 means in a basic medium. High pH means the amine part would be NH2 and the acid part will be COO minus, or the salt. So this is the form in which the amino acid would exist at high pH. Glutamine is shown, so that is the structure on top there. Now, which is a correct structure when aspartic acid forms a dipeptide with glutamine? In the previous question, we had the structure of aspartic acid, so that's this one. And we want to join it with the glutamine. Of course, we know that the acid of one amino acid joins to the amine of the other. And remember that the glutamine, this is the amine part, not the other NH2. The other NH2 is an amide. It does not react with acids. The NH2 is the one that will react with one of these acids. So looking at all the choices, which structure is correct, you will find that it is this structure in which the NH2 of glutamine is joined to the acid of the aspartic acid, but they joined it to the acid on the left, not the acid on the right. So that structure for aspartic acid is inverted. What is the maximum number of chiral centers in the dipeptide? So this is the dipeptide that we chose. Now, what is the number of chiral centers? How do we calculate, or how do we determine the chiral centers? You should know that a chiral center is a carbon bonded to 4 different groups. So looking at this structure, these are the chiral centers. Each of these carbons is bonded to 4 different groups. So we have a total of 2 chiral centers. A student prepared a sample of aspirin. The equation for the reaction is shown. The aspirin was recrystallized using an ethanol water mixture as a solvent, and the student determined its melting temperature using this apparatus. Now, this is an apparatus for determining the melting temperature, in which this is a beaker that has some sort of liquid in it. And remember, when he says the aspirin was recrystallized, you remember how to do recrystallization. We said if we're trying to recrystallize a solid, we dissolve it in a small amount of hot solvent, or minimum amount of hot solvent that will dissolve it, filter while hot to remove insoluble impurities, allow to cool, the crystals will form, and filter the crystals on cold to remove any soluble impurities, and then the crystals that are formed can be dried between filter paper. So this is how we do recrystallization. The student's sample melted over a range of 8 degrees starting at 125 degrees Celsius. The published melting temperature of pure aspirin is 135, which is a suitable liquid to go in the beaker. Now we want a liquid in the beaker that will be heated until the solid melts, and we're told that the melting temperature is around 125 or 135, and that means I need something with a higher boiling point. I cannot use water. Water has a boiling point of 100. It will never reach above 100. Ethanol is even lower, hexane is lower, and the only substance that I can use in the beaker would be. The second part of the question says, which is likely to be the main impurity in the sample of aspirin? So what was the reaction? This was the reaction. So we have 2-hydroxybenzoic acid reacting with ethanoic anhydride. It gives me the product that we require plus ethanoic acid. Which of these could be an impurity? Well, to be an impurity, it has to be something that will remain as a solid with the aspirin. Ethanoic acid, of course, is soluble in the solvent. Ethanoic anhydride is something that can react and be hydrolyzed by the water, so it would also not form a solid. Ethanol, of course, is liquid, so the only substance that can form a solid and mix with the aspirin is the 2-hydroxybenzoic acid. Grignard reagents are very useful for increasing the length of the carbon chain of organic compounds. Which metal is involved in the formation of a Grignard reagent? Let's remind ourselves, what is a Grignard reagent? It's a substance formed by the reaction of a halogenoalkane with magnesium. In presence of ether, this reagent can then be used to react with other substances to add that R group to that substance. So, what best describes the role of a Grignard reagent in increasing the length of a carbon chain? Well, what are the reactions that a Grignard reagent can make? Once we have made the Grignard reagent, we can react it with many substances to form the required product. For example, if I want to prepare that R group that I had, then I can react it with water. Or I can react the Grignard with an aldehyde, so this could be methanol to give a primary alcohol, or an aldehyde other than methanol, so that would give a secondary alcohol. Or I can react it with a ketone, and that means in all of these cases I'm adding the R group to the carbon that has the carbonyl. I can also react it with carbon dioxide. This would give the acid. So in all of these cases, the Grignard is acting actually as a nucleophile that attacks the slightly positive carbon of the carbonyl. Propanoyl chloride and N-methyl propylamine react to form an amide and hydrogen chloride, and we have the structures of these two compounds on the top there. The structures of the reactants are shown. What is the structure of the amide formed? Remember, when I have an acyl chloride and we're reacting it with an amine, the lone pair of electrons on the nitrogen will attack the slightly positive carbon of the carbonyl. The electrons of the carbonyl go to the oxygen and then come back and release the Cl in the form of HCl. So the nitrogen there of the amine is attacking the carbon of the carbonyl to form an amide. So which amide will be formed? You will find that it is this product. If 64.3 grams of the amide is produced, what volume of HCl is formed at room temperature and pressure? And we are told that we should assume that the relationship is a 1-to-1 ratio. We have 64.3 grams of this amide that we formed. We have the mass, so we can get the number of moles using the MR. So we first get the molecular mass of the compound. The number of moles would be the mass over that molecular mass. So, and then we're told that the stoichiometry is 1:1, and that means the number of moles of the HCl would be the same. Now, what is the volume? And we're talking about HCl as a gas. So volume is number of moles times 24, since this is at room temperature and pressure, and we end up with about 12 decimeter cubed. This question is about cell reactions involving chromium. Use your data booklet when answering this question. Name the type of the reaction that is shown in the right-hand electrode systems in the data booklet. Remember that the reactions that we have in the data booklet show the reduction of each of these species. Name the series formed when the right-hand electrode systems are placed in order with the most negative first. So that is actually what you have in your data booklet, the arrangement of the electrode systems with the negative first. This arrangement is called electrochemical series or standard electrode potential series. A student set up the following apparatus to measure the standard electrode potential of the right-hand electrode system 8 in your data booklet. So what is X and Y? If I look at the data booklet and I look at the reaction, of course, X would be the platinum electrode, Y is the chromium 2+ and chromium 3+. Remember that all solutions in the half cells have a 1 mole per decimeter cubed concentration. And of course, you look at your data booklet. So that is system 8 in the data booklet. Give 2 reasons why the initial reading on the voltmeter may differ from the value given in the data booklet. Remember that if we have a certain substance like chromium 2+, it could be oxidized while we're doing the reaction to chromium 3+ by oxygen in the air. Or remember that all the values that are given in the data booklet are at 298 K. So if the room temperature is different, then the reading could be different. The voltmeter is removed and the cell is allowed to run for 1 hour. Explain the changes that would occur in the right-hand half cell during this time. Now, if we remove the voltmeter and we allow the cell to run, then the chromium 2+ would continue to change to chromium 3+, and that means the concentration of the chromium 2+ would decrease and the concentration of chromium 3+ would increase. And of course, this is because the E cell is positive, so the reaction works. Explain by calculating E cell values why iron 2 is used to reduce chromium 6 to chromium 3, but zinc is used to reduce chromium 6 all the way to chromium 2. Now, if we look at the data booklet, we're trying to change chromium 6 to chromium 3 using iron 2. Of course, the data booklet shows the reduction potentials. Here we have oxidation of iron. You invert the equation and invert the sign. So iron 2 going to iron 3 and Cr2O7 2- going to Cr3+. We find that the E cell overall is a positive value. But if we try to use it to change chromium 3 to chromium 2, now the E cell is a negative value, and that's why iron 2 is used to reduce chromium 6 to chromium 3 only. But with zinc, what happens with zinc? Again, we get the numbers from the data booklet. And we find that to use zinc to change chromium 6 to chromium 3, that's fine. The E cell is a positive value. And when we use it to change the chromium 3 plus to chromium 2 plus, the E cell is also a positive value, and that is why the zinc can be used to reduce chromium 6 to chromium 2. Now we are required to write the numbers chosen of the right-hand electrode systems from the data booklet. Which equations did we get from the data booklet? These are the equations that we used to reach this conclusion. State the essential conditions required for these reactions to occur. Remember, all of these reactions are in acidic medium, so the presence of an acid is essential. Okay, question 15 says 2,6-dichlorophenol is used for communication between ticks, small parasites that can infect animals, including humans. The compound can be synthesized in the laboratory from phenol. 4-phenol sulfonic acid is formed in reaction A. This is then chlorinated. Hydrolysis of intermediate B removes the sulfonic acid, and the reaction scheme is shown. The sulfonation of phenol is similar to the sulfonation of benzene. So what do you think would be the reagents required for reaction 1? Remember, to add a sulfonic group on the benzene ring, we react it with what? Fuming sulfuric acid, which we said is concentrated sulfuric acid with sulfur trioxide. Deduce the structure of intermediate compound B. Now, what is the reaction again? He had this, and he was saying, if I have the 4-phenol sulfonic acid, first of all, we're starting with the phenol, and we added the reaction A to form the 4-phenol sulfonic acid. Now he's saying I want to add chlorine or react it with chlorine. When we react it with chlorine, we get this kind of product. We put the chlorine on the benzene ring at carbon number 2 and carbon number 6. Remember that the OH group is an ortho-para-directing, and the sulfonic acid actually is a meta-directing, and that's why it has to be on these carbon in the benzene ring. Explain why the reaction of chlorine with phenol occurs under milder conditions than the reaction of chlorine with benzene. Remember that we said the reactions with phenol are easier. Phenol is more reactive than benzene. This is because the benzene ring has delocalized electrons on the benzene ring. This makes it very stable. So in order to react it with chlorine, for example, I need a catalyst, an hydrous aluminum chloride catalyst. But if we have phenol, we said the phenol has the OH on the benzene ring. Its electrons are, or lone pair of electrons, are delocalized with the pi cloud of the benzene ring. This increases the electron density of the ring, makes the phenol more susceptible to electrophilic attack, so reactions with phenol occur at room temperature. An alternative synthesis of 2,6-dichlorophenol starts with this compound. Compound C is chlorinated and hydrolyzed, and then carbon dioxide group is removed to form 2,6-dichlorophenol. Other than the phenol group, name the functional group present in compound C. So what is the name of this other functional group? You should realize that that is an ester group. Identify 3 factors that organic chemists will take into account when considering alternative methods for an organic synthesis. How do we decide which procedure we should use to prepare a certain compound? you should realize that we should take into account, for example, the atom economy. The higher the atom economy, the better the sequence is, the percent yield obtained, whether this reaction will emit greenhouse gases or not, whether reagents are toxic or not. Also, you can take into account the cost of the reagents. All of these could be used to determine which procedure to use for an organic synthesis. The mass spectrum of 2,6-dichlorophenol is shown. And the question is, explain the relative intensities of the peaks. So if you look at the relative intensities, 162, 164, 166, why do they have these relative intensities? Well, this has to do with the fact that chlorine has two isotopes, chlorine 35 and chlorine 37. And you should be aware that these isotopes exist in a ratio of 3:1, or 75% of the atoms have chlorine 35, 25% have chlorine 37. So if we have this molecule with two chlorines, either both the chlorines are 35, in that case it will give a peak at 162, and the intensity or the relative intensity of that would be higher than if we have one of them chlorine, the other 37, or both of them are 37. Suggest why there is a corresponding set of peaks at 163, 165, 167. So these are peaks that have one more mass number. So that could be due to the fact that one of the carbons in this molecule is a carbon 13. Then in that case, the MRs of these three options would be one more. Question 16 says, metal ions occur naturally in river water, but near industrial plants, the concentrations can reach toxic levels. Wastewater from a stainless steel electropolishing plant contains dangerous concentrations of transition metal ions as aqueous complexes. Chemical precipitation can be used to remove these ions from the water. Complete the equation for the reaction of a laboratory reagent with aqueous iron 3 ions to produce a precipitate. So if we want to form a precipitate, what would react with the iron 3 plus? And of course the iron 3 plus, in solution is a complex between iron and 6 water. Now we can react it with what? We can react it with sodium hydroxide. That would give a precipitate in which 3 of the waters have been deprotonated to OHs. In that case, the overall charge on that complex is 0 because I have 3 positives of the iron and 3 negatives of the hydroxide. So this is the equation that you should get. This compound can also be used to precipitate metal ions from wastewater in acidic solutions, and we have this represented. Then we are required to complete the table for this. So what is the charge on the nickel ion? Well, we were given that this is the ligand that we have. It has an overall charge of 1 negatives. We have 3 of them, that's 3 negatives. So if the overall charge on the complex is 1 negative, that means the charge on the nickel was +2. What type of ligand is this? You can see that each of the ligands makes 2 dative bonds to the central metal ion. So this is called a bidentate ligand. What is the coordination number of the nickel ion? Remember, coordination number is the total number of dative bonds made to the nickel ion. This is a total of 6 dative bonds. What would be the shape of metal complex around the nickel when we have 6 dative bonds? They are arranged in octahedral structure. Explain using a balanced equation why the formation of the complex from an aqueous solution of nickel ion is thermodynamically feasible. Okay, so if we write this equation, this is the equation of the nickel 6 water with 3 of the ligands to form this product, that if it is thermodynamically feasible, that means the delta S system would be positive. As we see in the equation, we're changing a total of what? 4 particles and making a total of 7 particles. So more particles are formed, and that means the delta S system would be positive. When a 5 decimeter cubed sample of wastewater was treated with excess acidified or a compound of this, 245 milligram of the precipitate was formed. Calculate the concentration of nickel ions in the sample. So we had this equation. We started with 5 decimeter cubed of the water. We treated it with this acidified ligand to form 245 milligram of the precipitate. Calculate the concentration of nickel ions. So first of all, let's calculate the MR of the product. We are told that the MR of the part of dimethyl dithiocarbamate, which is the ligand, is 120. But then we also have 3 of them, and we have nickel, and we have an H+. So the total MR of that product is 420.3. Then I can get the number of moles of the product, mass over the molecular mass I calculated. The mass is given in milligram. We should change it to gram. That's multiplying by 10 to the minus 3. So I get the number of moles of the product. That means that the number of moles of the nickel that we started with is the same according to the equation. So I can get the concentration. The concentration would be the number of moles of the nickel that we got over the volume of the water. And the volume of the water was 5 decimeter cubed, so this is the concentration. Question 17 says, phenylglycine is an amino acid which can be synthesized from benzene. The first step of the synthesis is the formation of methyl benzene from benzene and chloromethane. Draw the mechanism for this reaction. Equations for the formation of the electrophile and regeneration of the catalyst are shown. So we're required to draw the mechanism of what? Benzene with chloromethane, and we know that this is in presence of aluminum chloride catalyst. So this is the mechanism. Remember that the benzene ring attacks the electrophile, which is the CH3+, and then the catalyst is regenerated by removing that H and returning the benzene ring to its original state. One of the steps in the synthesis is shown. Explain with reference to the mechanism why this step in the reaction sequence will not produce a single isomer. Now what do we have? We have the cyanide attacking the C double bond N. And we know that this C double bond N is actually a planar structure that can be attacked from both sides equally, and that is why we will obtain both enantiomers and forming a racemic mixture, so we don't just get one product. The final step in the synthesis is shown. State the type of reaction, the reagent, and the conditions. what are we doing? We're changing the C triple bond N to an acid group. That means I am breaking the C triple bond N. This is called hydrolysis using dilute acid, and we heat under reflux. That changes the C triple bond N to an acid group. Fuel cells are an alternative to internal combustion engines and batteries for powering vehicles. A schematic diagram of a fuel cell is shown. Question 18 says, fuel cells are an alternative to internal combustion engines and batteries for powering vehicles. A schematic diagram of a fuel cell is shown. Explain how a fuel cell works, discussing advantages, disadvantages, using the acidic hydrogen-oxygen fuel as an example. Include in your answer half equations for the electrode reactions and an example of another fuel that is suitable for use in fuel cells. So, if we're talking about the hydrogen-oxygen fuel cell and we're required to talk about the acidic hydrogen-oxygen fuel cell, remember that basically what's happening is the hydrogen reacts with the oxygen to give water. In acidic medium or in acidic electrolyte, the hydrogen loses electrons, becomes oxidized at the anode. The oxygen gains electrons and H+ and becomes water at the cathode. So basically what is happening, hydrogen gas and oxygen gas are bubbled through porous platinum-coated electrodes. The reaction in which electrons are given and taken, this generates a voltage. Now, we were required to give an example of another fuel that could be used for fuel cells is methanol. Now, what are the advantages? Remember, these hydrogen-oxygen fuel cells, they don't produce any greenhouse gases, no harmful products, because the only product that is obtained is water. They are also efficient and produce a lot of energy per gram of the fuel. Now, the disadvantage is the hydrogen, of course, is a gas. It has to be stored and transported and things like that in high pressure tanks. And in any case, hydrogen originally is manufactured from fossil fuels, which uses up the resources that we have. In recent years, there have been health and safety concerns over liquid tabs. These are capsules which contain concentrated liquid detergents. The soluble packaging breaks down upon contact with water during a laundry cycle to release the detergent. Some liquid tabs are small and colorful, which makes them attractive to young children who may be tempted to put them in their mouth or play with them. When moist, the liquid tabs can burst in a child's hand, potentially irritating the eyes and the skin. They can also dissolve quickly and may burst in a child's mouth in a very short period of time. This allows the contents to escape quickly. If swallowed, it can cause severe breathing difficulties. So based on all that has been mentioned, identify the hazard symbol that should be displayed on a box of liquid tabs. Again, you are required to know the hazard symbols. What was mentioned in all of this is that it is an irritant. So it was mentioned that it is irritating to the eyes and the skin. So the sign for the irritant, that's the symbol we should take. The capsule containing the detergent is often made from polyethanol and its derivatives. Draw the structure of polyethanol showing 3 repeat units. So what is polyethanol? This is polyethanol. Now, to draw the polymer from an alkene, we said this is addition polymerization. We look at the two carbons that have the double bond, draw them with a single bond, bond on the right, bond on the left, to show that they are attached to other units. Now, this is one repeat unit, and we're required to draw 3 repeat units, so you just repeat that 3 times. Use your structure to calculate the percentage of hydroxyl groups by mass in the polymer. So this was the polymer, and we're required to calculate the percentage hydroxyl groups. Of course, in this hydroxyl groups, we have 3 of them. So over the total MR times 100, this gives 38.6%. Explain why polyethanol is soluble in water. Now, this is polyethanol. It's something that has a lot of OHs, and we know that each OH can form hydrogen bonds with a water molecule, so we have a large number of OH groups that can form hydrogen bonds with water. In liquid tap detergents, glycerol is added to polyethanol. So this is glycerol. Give the IUPAC name for glycerol. We have, of course, 3 carbons with 3 hydroxyls. So this is propane 1, 2, 3 triol. So just one way that the properties of polyethanol will be improved by the use of glycerol. Remember, when we put 2 substances together, apart from solubility, what else could it add to the polymer? Well, when we have these kinds of mixtures, usually the polymer would be stronger. So that will make it more useful. Glycerol is added to the polymer at 0.11% by volume. Calculate the number of moles of glycerol added to 1 ton of polyethanol. Okay, so we have density. We're given density of the polymer, so I can use that to get the volume. Volume is mass over the density of the polymer. The mass is 1 ton, and you are already told that 1 ton is 1,000 kilograms, and a kilogram is 1,000 grams. So this would be the volume of the polymer. Now, if I want 0.11% of that, 0.11% of that volume is this. Now, we're required to get the mass. The mass of the glycerol is density times volume. Density of the glycerol is given times the volume. That would be the mass that needs to be added, but we're required to get number of moles. So number of moles from the MR, we calculate the MR of glycerol. Number of moles is mass over the molecular mass. That gives 12.7 moles. Polyethanol is made from a polymer intermediate rather than by polymerization, as ethanol is unstable. The polymer intermediate is prepared from a monomer X. When 1 mole of X is burnt, we have this volume of carbon dioxide and this mass of water, and we have an infrared. Use the information to deduce the displayed structure of the monomer of the polymer intermediate. So we're given the IR spectrum, and we are told that 1 mole of X burnt in excess oxygen gives this amount of carbon dioxide and this amount of water. So we can get the number of moles of carbon dioxide. This is a gas at room temperature, so volume over 24. Each mole of carbon dioxide has 1 mole of carbon, so that is the same as the number of moles of carbon. Now we have the mass of water. We can use that to get number of moles of water, mass over molecular mass. But each mole of water has 2 moles of hydrogen, so the number of moles of hydrogen is twice of that. Then we look at the IR spectrum. We have a peak, which is labeled P, that is for the C double bond O. And from your data booklet, you can see that the C double bond O is in the region for an ester, 1750 to 1735. We also have the peak at Q, which is for the C double bond C from the data booklet. Again, get these numbers. And that means from all of these information, we had 4 moles of CO2, 3 moles of water. It's an ester, so it must have 2 oxygens. From the balancing, I have C4 and H6 and O2. We also have an alkene, C double bond C, so this would be the structure of the compound. Some hospitals use polyethanol laundry bags instead of reusable washable polyesters. So we're talking about hospitals, and we're saying, why is it that when we use the polyethanol, which dissolves, we should use it instead of the nylon bags or polyester bags that we wash and reuse? What would be the advantage of the soluble polyethanol laundry bags? Of course, if it just dissolves and I don't need to wash it and reuse it, then there is less chance of contamination and less energy which would be needed for washing and drying. And that's the end of this paper. Please like, share, and thank you for listening.